right, so now we're going to look at navigation and applications. Angles have different ways of being measured. Standard position is measured from the positive x-axis with positive angles opening counterclockwise. The course of a ship or a plane is the angle measured clockwise from the north direction to the direction of the ship or plane. This is called course, is called a bearing. Bearing, true bearing, or compass bearing, those all mean the same thing, are direction angles given as rotations measured from clockwise to north. We also have quadrantal bearings, which is something we're going to talk about down here. So for this, it says convert the bearing of 220 degrees to a standard angle, and then draw the angle in standard position. So notice that north is 0 degrees, so north, east, south, and west. So north is 0, and east is 90. South is 180 and west is 270 degrees. But when we're talking about the standard angle, that starts here at 0 degrees. This would be 90 degrees, 180 degrees, 270 degrees, and all the way around is 360 degrees. So we're trying to figure out what this angle measurement would be in standard position. So there's a couple different things we could do. We could find the reference angle. We could also notice that the difference between these angles is that 90 degrees. So I'm going to do it one way first, and then I'll look at the next way. So let's say we were to take off this 90 degrees here. So we have 220 minus 90. So if we do 220 minus 90, notice we get 130. So that would be the distance from a standard angle from here to here as a negative angle measurement. So from here to here is negative 130 degrees. So if we want the positive angle, then we use our coterminal angles to find that. So 360 degrees, and then we take that 130 and subtract it. So 360 minus 130, notice it gives us 230 degrees. That's just one way to figure out what the standard angle measure is. We could also use, like I said, reference angles. So if instead I wanted to use a reference angle, remember the reference angle is the positive acute angle made by the terminal side and the shortest angular distance to the x-axis. So this would be the reference angle here, which I'll call theta prime. So if I know from here to here is 220 and all the way to here is 270, well, I could do 270 minus 220, which gives me a reference angle of 50 degrees. So if I know that's 50 degrees, that's this measurement from here to here, then I could do 180 plus that 50, and notice I get 230. So it gets you the same answer in the end, it's just a different way of going about it. Could I have instead figured out what the measure from here to here was? Sure. Normally I don't do that side because usually we always use the x-axis because it's a reference angle, but if we did this side here, that would be then 40 degrees. So then you could do 270 minus the 40 and you would get 230. So a lot of different ways of looking at these problems, and again, just use kind of what works for you. So if you like to use the reference angles, you can use the reference angles, or you could think about it the first way that we did the problem, first figuring out that the negative angle measurement from here to here is negative 130, and then adding the 360 to that. So let's look at a bearing of 160 degrees. So we're going to go ahead and sketch this first. 160 degrees would be in quadrant 4. Because remember, this is north 0, 90, 180, 270, so it would be down here, quadrant 4, so that would be the bearing of 160 degrees. So again, the difference between this and drawing our angle in standard position is that extra 90 degrees that we have. So we could think about taking this 90 degrees off. So 160 minus 90 tells me that this measurement from here to here is 70 degrees, or if you wanted to think about it like a negative angle, it'd be negative 70 degrees. So if we took 360 minus that 70 degrees, notice we get 290 degrees, which would be all the way around. So again, first I took 160 degrees minus 90 degrees to get the 70 degrees, and then 360 degrees minus the 70 degrees. And that's also the reference angle in this case is the 70 degrees. So again, that's this angle here is negative 70 degrees. So you again, think about it like coterminal angles. 360 plus negative 70 gives us 290. Looking at the next one, we have a bearing of 335 degrees. So 335 degrees is going to be in the second quadrant because it's in between 270 and all the way around back to north would be 360. So that's going to be somewhere up here. So all the way around to there. So if we want to figure out what this angle is in standard position from here to here, again, notice that the difference is that 90 degrees here. So we could figure out the negative angle measurement and then add 360 to that. So from here to here is going to be equal to, if we go, so take the 90, so 335 degrees minus the 90 degrees, which gives us 245. So that means this would be a negative angle measurement of 245 degrees. So if we want the coterminal angle, remember coterminal angles, you add and subtract 360. So 245 degrees plus 360 degrees is equal to 115 degrees. Of course, that's not the only way we could have solved for this. If we wanted to find the reference angle would be this angle right here because it's a positive acute angle made with the terminal side and the shortest angular distance to the x-axis. So if we wanted to find that angle, we could take the 335 and subtract it from 270, which means that this angle from here to here as a reference angle is equal to 65 degrees. So then we could have taken on our standard angles from 180 is to here, remember, so 180 minus then the 65 gives us 115, so that's another way to look at it. Also, we could have figured out what this angle measurement is here, so if we took 90 minus that 65, we can see that that's 25 degrees. So if we took then 90 plus 25, again, notice you get 115. So these are all just different ways of finding that standard angle measurement, which again was 115 degrees. So just use what works for you. So if we have a bearing of 36 degrees, again, bearings from north going clockwise, that would be going this direction. So then if I wanted the standard angle measurement, then I'm trying to figure out from 0 going this direction what that standard angle measurement is. So if we take 90 degrees minus 36 degrees, we get 54 degrees for the standard angle. So with the exception of quadrant 1, an easy way to think about this is what do we do each time? So we had that extra 90 degrees, right, that we had to subtract. And also we then found the coterminal angle by either adding by taking 360 and subtracting the angle or adding it. So, whoops. And so here's a little trick. You could do 450 degrees minus the bearing to get the standard angle. And again, you don't need to do that in the first quadrant. If you're given angles acute, it's just 90 minus that. But if it's in the other quadrant, so just to show you up here, so again, we first subtracted the 90 and then we did the coterminal angle. So if I take 450 and subtract 220, notice I get 230. So just another way of looking at it. So same thing with the next example, 450 minus 160 gives me 290. And over here, if I were to take 450 minus 335 degrees, I would get 115 degrees. And again, that's because we subtracted the 90 and then found the coterminal angle. So for this one, again, you wouldn't want to do that because it's 36 degrees, because if you did 450 minus 36, you just have to subtract 360 again. So just doing more work than just taking the 90. So then those are all, of course, coterminal angles, but we only need from here to here. So let's go ahead and look at the directional bearing, which is also called quadrant bearing. Directions are angles given as a starting direction, either north-south, and then an acute angle of rotation measured towards the second direction, either east or west. And sometimes people write them the other way as well, so you just have to be kind of careful of how you're looking at it. So for this first one, it says a bearing of north and then 20 degrees to the east. So that means, again, you would start from north and you would go east 20 degrees. So if I want the standard angle, that would be from here to here. So the standard angle, we would take 90 degrees minus 20 degrees, and that gives us 70 degrees for standard position. Then for this one, it says a bearing of south 41 degrees east. So here's south, and we're going 41 degrees towards the east, so that would be here. So basically, we need to figure out our standard angle measurement so we can find out what this angle measurement is. So if I take 90 degrees minus 41 degrees, I get 49 degrees. So this would be negative 49 degrees if you want to think about it as a standard angle. So we're using 49 degrees as a reference angle, which is a positive acute angle. So if that's 49 degrees, remember then all the way around from here to here would be then 360 minus that 49, which gives me 311 degrees. For the standard position. So we're going to do the same with these. Sketch the angle given in bearing and then determine the angle measured in standard position. That's coterminal. So we have a bearing of north 60 degrees west. So north is at the top and we're going 60 degrees to the west. So that would be this direction. So that means I want to figure out the standard angle from here to here. So that means we need to add 90 degrees to 60. So 90 degrees plus the 60 degrees is going to give me my standard angle of 150 degrees. If you wanted to use reference angles, you know that this reference angle from here to here would be 30 degrees. So you could also do 180 degrees minus 30 degrees, which gives you 150 degrees. That would also work. If we have a bearing of south 11 degrees west, that would be here. And then so in standard position, we're going all the way around to here. So I could do, I know from all the way around here is 270. So I could take 270 and subtract 11 and I get 259. So that would work. That's one way to do the problem. Or I could figure out the reference angle. So we know if that's 11 degrees, then 90 minus 11 means the reference angle is 79 degrees. So then I could do 180 plus 79 and also get 259. And why are we doing this? Because when we are going to do application problems, we need to have the standard angle in order to use our calculator to calculate these measurements that we are going to have. And so that's all for today. And then tomorrow we're going to work on the applications.